Hi there, and welcome to another session for the course Data Analysis with Python. I'm personally proud and impressed that you have stayed on up to this point. I would like to just take a brief moment to commend your patience, your persistence, and generally your willingness to learn. Yeah, you're doing really, really great. And I just want to say I'm really proud of you for sticking on up to this point. Uh, so, up to this time, we've learned a few things regarding Python as a language. You now know what data types in terms of variable types in Pythons, integers, strings, and the likes. You know things about functions, you know about loops. We also touched on classes in our previous session, and in a nutshell, that is a big part, or should I say, a big knot, a very big knot, like in general, generic knot of what Python is about. But like a rubber band, you know, you keep stretching, keep stretching, and there's still so much, to know. But what we have covered so far are building blocks, in which we just add more things to it. But your foundation at this point, it's now, really seated there. So delving into it, up until this time, we haven't really worked with data, and I know that's one of the main reasons why you signed up for this course, to know how you can analyze data using Python. So in this course, we're going to be exploring a little bit of data, speaking to data. And for that, we're going to use a library in Python. Okay. So a library in Python, just similar logic, or explanation as to what functions classes are for, to help you to avoid rewriting blocks of code from scratch, so some fundamental parts of a particular operation. I'm trying to refrain from using the word function that have already been written down, and so you can just build on it, and that's what functions, classes help us with. So here we can now write our own function, write our own classes, as the case may be. But more importantly is that with libraries, there are some classes that we don't even have to write. Some other person or team has taken out the time to write what the particular operation that we wish to carry out already in a class. So all we need to do is identify such libraries, okay, such libraries, and locate the classes that have been written down already or documented in the library or functions, and just make reference to them to add to it. So it also helps us to perform our tasks faster because we're not reinventing the wheel. So we're just building up on what others before us have shared. Okay. Having said that, the library that wants us to look at first is NumPy. Okay, so the pronunciation might be different, but the spelling is the same. So I'm just going to increase my zoom level here so you can see. So the spelling is NUMPY, NumPy. You could, it's like an acronym, say numerical Python. Okay, so you already kind of have an idea. Numerical Python, so numerical. So we're dealing with like data types that speak more to numbers. However, it also makes provisions to non-numeric data types. String variables are also allowed in NumPy. Now, to use a library in Python generally, we have to import it. So you've been following up with this course. So if you've gotten to this point where you're using a code editor, I like I said from the onset, we're not confined to a particular code editor. I'm using Visual Studio Code for this. You could be using something else. You're using Atom, Anaconda. They all work just fine. However, when you want to use the library, you have to import it, okay? And so you use the keyword import, okay? Import. So I'm just import and numpy, so just numpy, right? So when you import, so the keyword import has to be clearly spelled out, and then the name of the library that you want to import, followed by an alias. Okay, so it's good that you use an alias because as you're referencing the library, you're referencing um, objects from the library, which are basically classes, functions, methods in the library. You need to have an alias. So that's why I was so or you can see that IntelliSense is already giving me that auto completion bit there. So I say import the name of my library. The name of the library we're talking about today is NumPy as, so that's how you use an alias. So basically, alias beyond programming is a term that we use in other conversational spaces. Okay, I remember as a young teen growing up in secondary school, we did have nicknames. So nicknames are aliases as well, and sometimes in our nicknames we had aliases. So I had mine, and then it was a Berama alias this. So here, instead of writing alias, we just say as, and then you specify what the alias is. So NumPy is commonly expressed as NP, but you're not confined to it. So if you want to, you could use something else. You could use something else for um, for your alias. You could say CP, DP, but more commonly you're used to express as NP. Okay, it's good to also know what is commonly used. So if you have to review someone else's code or you're working as a team and someone has already done this first bit, so you can just flow along. However, if you have a particular preference and you want to say PN, you can go ahead. You're not even confined to two characters. Okay, you just do what works best for you. Okay, so now it's imported in there. What's the next thing to do? So with the NumPy, there are several things that we can do with the NumPy library. But one of it is, since it's numerical Python, it's about working with I'm just going to constrain this conversation to say working with numbers, okay, working with numbers as our data type. Yeah, as our data rather, working with numbers. So numbers, we have different data types for numbers. We have the integers, generally whole numbers. We have floats, decimal numbers, and then there are some other number types which you had also read up following our earlier conversations. So NumPy allows you to create this number like a variable to house numbers and variably sorry I said the word variably. So when we're saying housing numbers, we're speaking to like list, but we use a method right in NumPy because we want to create an array. So I'm just going to say um, variable one. I'm just going to say variable one, and since I'm saying np here, np dot. So you recall from when we were working with classes, so we said once you want to reference something from a class, right? You want to reference something from a class. Once you've imputed like that object, so in this case here now MP is an object of that NumPy class. You now want to reference a method which is a function in that class. You do it by you do it using the dot notation. So that's why I was saying MP dot. So the method I want to reference here is array. Okay, array. Now it's important that I just write it out like this. So the array is a method. Now you can look at the official documentation to see how it's being defined, in that class of its own there. The array method allows you to have lists. So list of data. So your data could be numbers, could be integer, it could be strings, as the case may be. However, the major thing about the syntax is you're referencing it, so in this case MP dot, but the name of that method must be specified there as array and then parentheses. Now it allows you to house list. So I've already worked with list data type. So I'm just going to say list data type, and I'm just going to run with this. So remember what the lists are. square brackets, right, that are mutable. That means you can edit the entries, in the list. However, with NumPy, it still allows you, to have this list. But one of the advantage of, or if with the native Python environment we could create lists. So why are we still having a NumPy that also allows us to create lists? Is that the NumPy, it is faster. So it allows you to perform operations with list. If I'm to use say word list, it allows you to perform operations faster and general efficiency. It also gives you privy to certain functionalities, within that NumPy library. Okay, so having said that, if I were to just print var1, right, I'm just going to say var1, which is that NumPy array there. We just see that array is missing a required argument. Okay, missing required argument. So now that's because it's expecting a list in here. And so what do we have in our list? Remember, our list has to be made up of square brackets. Okay, so now if I execute, yeah, oh, sorry about that. So it's an empty list. Okay, let's just do this without. So you just get the picture there where it says it's requiring that position argument list. So I'm passing an empty list in here, and so it just computes this empty list. So in here now I can have values, so I would say the 1 2 3 4 5. Let's just allow it that way, and we have list of values in here just the same way. So invariably you can say that var1 and list1 variable, they both have the same components. But with the NumPy, we have more things that we could do. Okay, so you always don't want to work with a list like this. And for the record, as we get deeper into it, it's also good to specify certain things. So when we see the list, an array, so I'm going to now delve into the word an array such as this. I'm just going to comment this out here. Okay, so when we see an array such as this, where it just has one list, one list in it, it's a one-dimensional array. So meaning that it's just as we're saying it here, you know, sequence of numbers, or characters. Like we just call this var2 here, and I'm going to say mp.array again, right? But this time around, I'm just going to pass strings. Okay, I'm just going to pass strings. Let me just say name, age, hobby. Oh, thanks for that. And let's just skip this. Yeah, that's two and execute. So you can see that the numpy array still passes this. So like I was saying, when you just have a list in here such as this, all right, you just have this um embedded in the list is just sequence of numbers or sequence of characters. It's one way. So I'm actually trying to save the word I want to just say. It's one way to say that it's one dimensional. So you just come in, just one way. You can think of it as your data being structured. So it's just a single column, right? A single column. If you are able to study matrix in mathematics, you would also be familiar with one dimensional, two dimensional. The dimensions could expand as the case may be. However, this is a one-dimensional array. So that means if we were to put it, it would just be like a single column or a single row. So you can just picture it mentally. If the values, the content of the list are not so much, maybe you can say, oh, it's a single row. 1 2 3 4 5 6, name, age, hobby. What if it's as long as, if you want to picture it as, oh no, it's a single column. However, when we say um, sometimes our data, realistically speaking, is not always one dimensional. Okay, so where we have name, age, you could also want to have entries for or values for this name, age, right? Think about it. You could also want to have values for this name and age. So I'm just going to change this up here. Now, in here, I want to create another one. Okay, so in here, I'm creating another list. So in this list here now, I'm just going to work with what IntelliSense I said there. Um, so in here now, we have two lists. Okay, I'm using the word list because that's how we've learned it up until now in the class, right? We've said list anything in square brackets, and we also know that we had mentioned that you could nest list. So the numpy allows you to just, as an array, embed that. So now look at this here now. So we were saying there's this first list here in the array, and then there's the second list in this array. It's different, yeah, not just the volume of the content of the array, but the structure of the array is different. This one, var2, var2, just like var1, is one dimensional because it just following just like a flat line, just one flat line, just flat. Okay, whereas this has two. So there's this first bit here and there's the second bit here. So it's two-dimensional. A two-dimensional array is what, a perfect way to just describe a two-dimensional array is rows and columns. Okay, rows and columns. And if I were to just add this up here, okay, so I'm just going to do this. Now you can see that for the second bit here now, name, I'm saying Belema here, age 25, hobby football, right? So the two-dimensional array represents a table. Okay, so for two-dimensional array, um, I'm going to just say this the way it was, the way I learned about matrix. Okay, is that when you have your things in parentheses, brackets, it's denoted with M and N, right? M and N, okay, where M is rows and N for columns, okay, and this is so let's just put this in quotes so we don't have errors thrown. We don't have errors thrown. Mhm. So we're also going to comment this out so it doesn't distort anything. So just think about it. M for rows, N for columns. So for this one dimensional array, we just have M, I guess. Whereas for the two-dimensional array, we have M and we have N. So that's why it's going to be easy to see, to view it as rows and columns. Okay, so the first the first list in the two-dimensional array, all right, rows and then columns. Now if I were to view data, based on this ID here, so I can just view the data here to say, to look at that's var3. Okay, we'll get back to this later. I can see name, Belema, age, hobby, football, you know, and you can just keep adding to it. Now, if you add, now important to note when I said keep adding to it, if you add another value here, that's another list, it's now going to be a three-dimensional array. So the way you also interpret a three-dimensional array, it now kind of goes out of this concept which I just explained of M and N. Okay, so a three-dimensional array has another explanation to it, which is basically the first bit of three-dimensional array. I'm just adding X in here. So in that instance, X would represent like a group, like you're trying to just group these sets of data. So after that, the next bit, or you can think of it to say the last two um, lists in an array represents rows and columns. But that's not what we're getting into right now. Okay, the bit of rows and columns, two-dimensional array is speaking to what is referred to as the shape of the array, and you can simply easily find out the shape of array. So I'm just going to say print. So let's see, using f in here, the f string. Okay, so I'm just going to say print. Oh, sorry, all that. Print shape of array. Okay, shape of array. And so we just reference the numpy array dot the keyword shape. IntelliSense already has that running in, so I'm just going to let that be. Okay, so I'm going to do same. I want this all to run. Okay, so what I'm saying here is the shape of array 1 is this, the shape of array 2 is that, and I'm going to just add there var 1, also going to say var 2 in here, and 3 in here, and run this. So now let's look at this, to try to understand this. So I'm saying shape of var1, which is array 1, the first array, it says 5 in parentheses, a comma, there's nothing in here. Shape of var2, which is r2, 3, comma, there's nothing in here. Shape of the third array, it says 2 comma 3. So just like I explained earlier, where it's just two entries like the metrics, which I learned, m and n. So these 2 and 3, what 2 and 3, all of this is telling you that it's looking at the content of the list. So in this first case here, it has just 5 entries, right? So you just tell it has 5 entries. So if we're thinking about it as rows, with M and N concept I just explained, so or columns, so it has 5 columns, so it has 5 rows, and the next one, name, age, hobby, so it's just three entries in that list, and there's no other list in this array here. So because that's why it just has 3 comma and then there's nothing. The third bit, because it has two lists, so it checks, the first list has 2 entries, or two value, or 3 value, sorry, I think that again. So it looks at this third array here now. So we're saying 2 and 3, and I said, so when you see 2 and 3, we're saying that just two values here. We're saying rows and columns. I just seem to be getting caught up in my head here. Rows and columns. Okay, so now let's look at it. Rows and columns. 1 m, right? This m, right? M, that's 2. Okay, because we have first list, second list, and that's m. All right, so that's why it's telling you here, like, we have 2 rows, we have 3 columns, right? Because the two-dimensional array typically represents a table, whereas if you have more, then let's just have a fourth one. So a fourth one to say mp.array, and in this one we're going to just have a third bit to it. Okay, so let's go let's go for this. And now we're going to start by saying title. Oh, nice. So title, author, book, author 1, book 2, author 2. Okay, I think I'm going to I'm going to run with this. So let's look at this here now. Let's look at this and try to guess before we execute. Okay, even if we execute, it's not showing anything here. Let's try to guess what the shape of this array is going to be here. So how many lists do we have in this array? We have this first list that houses title author. We have the second list housing two items here. We have the third list housing two items here. So that means this is a three-dimensional array. Okay, a three-dimensional array. So now if we're to print this, okay, to print this and execute, what do we see here now? Let's work together. Okay, so we have what I remember what I said. When you have a third value in it, the first part is looking at it as you grouping it, is reinterpreting it, you're grouping it, and then the next bit we're now speaking to the rules, ROWS, right? The rules and then our columns. Okay, so this is basically how NumPy works with array. First is the first teaser of NumPy working with array. You can create your arrays, by passing your values in here. And NumPy also has other methods that you could also deploy. So you could also, so let's work with another variable here now. And this time around, um, we're going to use another method. We're going to call another method from NumPy. Okay, and I'm going to just use random. Okay, random, and the random values I want in here. I'm going to say random integers. So that's for random int in here. So basically, with the random, with normal random, you specify values that like a range of values that you want, numbers that you want generated. So there's a base, a minimal value, and then there's like the ceiling top value of values of numbers that you want generated. So we were saying in 30 seconds, saying 10, 100. I'm just going to say 50 to say 90. Okay, let's just try to take it out of you. I was saying something about size. Okay, so with size here now, you can get the picture of it's trying to say, oh, how many rows and columns. Now, if we do not specify a size, I'm not going to specify a size for this first bit here. If we do not specify a size and we go ahead to just print, um, we go ahead to print this, we're going to just see a one-dimensional. So random number generated is F5 in here. So let's just print where 5 and shape. So int it has no shape. Okay, so I just wanted to print just the value in there. So it just keeps changing, generating numbers. However, if at this point here we had specified, okay, the size, so size 32 would mean that we're saying 3 rows, 2 columns, 3 rows, 2 columns. And so when we execute, so we can see what now? 1, 2. I was saying random generated is this. This is out of it. And then what we have here now is what? 1, 2, 3, right? 3 rows, 2 columns. So this was the first bit, and then it executes again. 1, 2, 3. Can you say 3 rows? 1, 2, 3, right? And then the columns 1, 2. If this is a bit confusing, I'm just going to comment this first bit here and then execute. So we see 3 rows. First row 1, row 2, row 3, and then 2 columns 1 and 2. Okay, so there are other operations that we could also perform using the NumPy library. We could perform various arithmetic operations. We could do average, right? So you could just say instead of merely printing, we could also take it a step further. So I'm just going to just add this in here. But instead of shape, I'm going to say the mean. Okay, this is what I want returned. Okay, the mean. And escape. So print. So we still have it. It prints var5, which is three rows, one, two, three, two columns, and then saying um, the mean. Sorry, I didn't specify the mean. Okay, so three rows, two columns, and so the mean is, so the mean, it adds up everything. We know what mean is: average. Add up everything divided by the count, of that. So if you just use, perhaps you have a calculator, you want to just confirm the arithmetic accuracy of this value in here, you could just do it quickly. Add them all up and then divide it by 6. You should have this value returned in here. Okay, so at this point, I'm just going to take a back seat and allow you to get your hands, or, oh, there's one more thing. I think there are a few more things. I won't just leave it hanging in here. Okay, so so you've seen mean, other operations that you could also use, just like when we worked with the list, how you can pinpoint particular things in a list, based on its position or its index. Similarly with the numpy, because it's basically an array of lists, group of lists. You could have a single list or multiple lists, as you've seen in here. You can also specify to say, hey, I want um, I want you to tell me where. So I'm just saying position position of second item, second row, second column. Okay, so for this, we're not going to say shape. We're just going to go and remember how we did this. So what we say is, you use same way, the list is created to reference it. So in this case, if we're saying second row, we know that the first position of everything is 0, right? So it doesn't count 1, 2, it counts 0, 1, and then the next I'm also going to say is this. Okay, and when we execute, if we look at this 62, 61, 58, 81, and what we're looking for was the position of the second row, the second column. So that would be, this is the second row here, and then the second column value should be 81. So you can see equation of second row of column by is 81. Okay, now that's one thing that you could use. I think another thing you could also use for this is from the numpy library, the where the where method. Okay, so the where method helps you to find things in an array. It returns the particular position of the value you're looking for in the array. If you use SQL, right, write SQL queries, you'll be familiar with the where clause. Perhaps on the channel, you've also taken our SQL courses and also even some of our advanced Excel classes. You would have seen us using those keywords where. So similarly as well, in the NumPy, you could also use where. To actually practice this, do I have to create another variable? No, I don't have to. So I'm just going to use this value here. Okay, so I'm going to call this bfinder. Okay, that's what I'm going to call it. I'm going to call it bfinder. And I don't know why ItalySense is just messing this whole thing up here. So I will say bfinder np dot where, right? And so bfinder, ItalySense doesn't know. I'm looking for where Belema is. Okay, so np dot where. So where var3 is equal to now you recall that when we looked at symbols, If we say equal to, I will say Belema here, you know, and I go ahead to say print bfinder, okay, and I say print bfinder, such as this, we get an error, okay. Without looking at the error, which I always implore you to, can you recall why we're having this? Okay, you have 5 seconds. Time up. Okay. So if you recall, and also if you could also refer to those earlier videos where we said the equal to symbol, just on its own, a single equal to symbol is used to assign values. Okay, whereas when you're trying to check if a condition is met, you're checking for criterias. We saw this one when working with conditionals, with the if, we saw it with the if, and also when we're also working with loops. When we're working with conditionals, you can't use a single equal to, so the equal to is used to assign. So to check if something is true, we say we use double equal to symbols. In some spaces, a third one is even introduced. Okay, find out why a third one isn't introduced. Now, having imputed a second equal to symbol, and I run this, we don't have an error returned. Okay, so if we try to just locate what this where this error what this print statement is, I think it's best if we just you know write something for it there. I just need to embed this here. Okay, so I'm going to say the position of Belema is, so I'm going to just run this again. Position of Belema is this. I need to close this up here. Okay, escape and run. So the position of Belema is, so we're saying array1, array0. What does this tell you? Okay, so let's look at this. Array1, that means it's looking at is the second position in that array there, the second list, and then the first item in that second one. And let's check to see it. So that was var3, right? So the second item, because that's what one is. So the second item in this array here, which is this first list, and the first item in the list, so that's 0. So we can see the position returned in here. So these are some ways that we are able to manipulate data, work with data using Python, and deploying one very key library used for data analysis in Python, NumPy. I would implore you to look up the official documentation. I'm also going, the link is also good, is also contained, in the description of the video. Look it up, and areas where you have questions, do not hesitate to share. And in our next class, we're going to delve deeper, look at other libraries, to help us work with data and start analyzing the data. I'm sure you can't wait. I can't wait as well. All right, so that's all for today. Thanks for watching, and I'll see you in the next one. Bye for now.